My name is Jimena, and today we're going to explore projectile motion. So, our goal in this simulator is to hit the target that is 15 meters away from where the cannon is placed. So, we have to adjust here some values and things. For example, we're going to use a golf ball. We don't have any resistance. Gravity 9.81. And let's try it first with 50 degrees and 15 meters per second. So if we fire the projectile, we get that it is a little bit far away from the target. And with this tool, we can measure it. It's like 7.59 meters away from where we want it to be. So let's try going lower. And when we go lower, we can see that there's a little bit of change, but it's not enough to get to where we need. So let's try moving the cannon up over there. And okay, with 59 degrees, we can see we're getting closer to it, but we still have a long way to go. So let's do 65. Okay, we're getting somewhere. We can appreciate that it's not that far away right now. It's like maybe 2 meters or so. Okay, 2.34 meters away from it. So let's do 70. And we fire it. Okay, it hit the target kind of in the middle, but it's not perfect. So maybe we can try 69. Okay, so they're both hitting the target, and they're not exactly in the middle, but they work. So mm, let's fire the first projectile for 69, and then the second one for 70. Okay, that's good. So first of all, we have to determine the range, height, and time for these two trajectories. So let's write it down over here. Okay, we have initial velocity, it's 15 meters per second. Then we know that the gravity is 9.81 meters per second squared, because it's acceleration. And then we have, okay, let's do first the one with 70. So we get that the angle is 70 degrees. We don't know time. We don't know how far it travels. We don't know what else. We don't know. Oh, okay. We don't know maximum height. Okay, that's good. So the first step to calculate the first step to obtain all of these variables is to look for time, as is the connection between both vectors. So let's begin with the tracker formula. So it's Sy equals 1/2 time acceleration time t squared plus VIY times t. Okay, so we know that the displacement for the, okay, I'll write it here. We know that the displacement for the y vector is 0. Why? Because when you have like your line like this, and then this is your trajectory. Okay, there we go. Your displacement from y, it's going to start here at 0, and it's going to go back to the ground, so it's going to be at 0 as well. So we know that 0 equals 1 over 2 times the gravity. Okay, so we're looking for time right here, and time can't be negative. That's why we're using the value of gravity as it is. And then the variable t squared plus the initial velocity, that is 15 sine of 70, as it is a vector, times t. Okay, it's looking good. Now, this one goes to the other side, like, okay, 15. Okay, so let's use acceleration series. Okay, so it's adding, and it goes to the other side, subtracting. Sine of 70 times t equals 1 over 2 times minus 9.81 times t squared. Okay, so we have to move the t's to just one side together. And what we're going to do for this is first is 1/2. We're going to move it multiplying as it is dividing over there. Minus 15, so 70. Wait, no. It's subtracting, so it's okay. Huh. Okay, so it comes here multiplying 15, so 70 times t. But what we're going to do with these t is that we're going to move it to the other side. And as it is multiplying, it goes to the other side dividing. But first, we're going to take this 9.81 over here, dividing as well. Okay, minus 9.81. So in this side, we have t squared over t. We know that this is equal to t. So here we have the equation. T is equal to minus 2 times 15 sine 70 minus 9.81. So now we go to our calculator. We type 15 sine of 70. And that is equal to 14.09538, blah, 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 blah. And this one is times 2, okay? So now we have 9.81. We're going to do this all together to save time. So it's time 2 divided by 9.81. And this should be 2.8736777739, which means time it's approximate to 2.8737. Okay, it's looking good. Seconds. So we got the time, and our next step is to calculate how far it traveled. So we all know the formula for this. That is velocity equals to over t. Okay. So we know velocity. As velocity here, it's on the x-axis, like this. We use cosine. If it's on the y-axis, we use sine. But okay, in this occasion, we're going to use cosine. 15 cosine 70 equals to d over, and we know that our time is 2.8737. So plus 70. This one over here is dividing, so it goes to the other side multiplying. And that is equal to d. So we type that into our calculator. Sine of 70 times the time. Okay, and we get that it traveled 14.74 2835.08, and then D it's approximate to 14.7428 meters. Okay, so after this, we only need to know the maximum height it reaches, which we'll obtain by using the tracker formula again. So we get that as y is equal to 1/2 times acceleration times time squared plus vi times t. Okay, we want to know si, sy, and we know that our time is 2.8737. Now, the time we'll need to reach the maximum height is exactly in the middle, which means that the time to reach the top is going to be half of the total time. So time up it's equal to 1.43683887. With this in mind, okay, approximate to 1.4368. Okay, we don't know sy and half. It's 9.81. 1.4368 squared plus 15 sine of 70 times 1.4368. Okay, Now we just type this in the calculator. The first part is minus 9.81 times half of the time squared, and that's equal to, hold up, first square the time, then multiply times minus 9.81, and we get that's 20.25, but it's divided by 2. So we get that it's minus 10.12640163 plus then, okay, now it's 15 sine of 70 times the time, and that's 20.25, 280325. That means SY is, okay, minus 10 plus 20. Hey, 10.1264016 SY is approximate to 10.1264. Okay, so let's time to check with the simulator. And okay, what I want for 70, I think it's this one. Okay, we got that our time was 2.87. Okay, here we go. Here it is, 2.87. It has the same there. Then the range, that is how far it traveled, 14.74. Same that it says there. And now we have to do the maximum. Just give it this one. Okay, I think it's there. So the maximum height it reached, it's rounded up 2 decimals, 10.13. But we proved that it's correct. So last but not least, let's analyze another cases. For example, if we did a cannonball with no air resistance, that's important, it'll follow the same trajectory. We can see here, it's a cannonball and it's the same trajectory. But if there's air resistance, the cannonball, it's not that affected because of its weight. Okay, we can see like very little difference. But then we have a golf ball that is lighter, and we can see that its trajectory, it touches the target, but far back from where it was. And now, last but not least, let's analyze how some variables are related. For example, the angle and the length it reaches. So here we have 70, and we can see it reaches 15. But if you go down, it goes farther away. If you go up, it goes closer. So if we know that here at 90, it's going to just go up and down on the same place, like its displacement is none from both sides, Uh, the max, and here, well, I can't do 0 because there's a ground, but okay, the max, like the farthest we can go, it's with 45. Okay, because it's a middle point between 90 and 0. And we're going to check it here. Well, no, with this one. Range. Okay, 22.94. And then let's do 44 to prove my point. 22.92. 22.92. 45, 22.94. It's almost, there's almost no difference. And then 46. And there we go. Back to 22.92. So that's the relation between those two variables. And that's all for today. Thank you for watching.